a uniform rod of mass m and length L is suspended from a rigid support. A small bullet of mass small m hits the rod with velocity v and gets embedded into rod. The angular velocity of system just after the impact is. See here, we are having a bullet of mass m which is moving with velocity v, and it will strike that suspended rod at one of its end, and it starts rotating in a circular orbit of radius equal to length of that rod. Now, as far as angular momentum of bullet is concerned, see here, bullet it remains embedded with rod, means that bullet starts performing circular motion. So, what is the angular momentum of bullet? Angular momentum of bullet. We know what is angular momentum of bullet about pivoted end of rod. Angular momentum of bullet about pivoted end of rod is equal to L is equal to m into v into r. R is the radius of circular orbit. Here it is nothing but length of rod. So, it is mass of bullet into velocity of bullet into L. Into what? L. So, this is length of rod, and here L represents the angular momentum of bullet. So, there is a difference between this L and this L. Now, when bullet gets embedded, both rod and bullet, they start performing circular motion. So, the angular momentum of system after collision, 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 L dash is equal to angular momentum of rod. What is angular momentum of rod? L is equal to I omega, angular momentum of rod about one of its end, plus angular momentum of bullet, so it is I2 into, because both that bullet gets embedded with rod. So, both rod and bullet, they will move with same angular velocity. So, that is why omega is same. So, the angular momentum of system after collision, both rod and bullet, they will rotate. Now, this rod is rotating about one of its ends. So, what is moment of inertia of rod about one of its end? It is ml square divided by 3, into angular velocity omega. Now, as far as moment of inertia of bullet is concerned, it is mass of bullet into what? Square of mr square into omega, but here r is nothing but r is equal to length. So, it is ml square divided by 3 into omega plus angular momentum of bullet. Now, it can be written as ml square into omega, Now, here L square omega can be taken common. So, angular momentum of system after collision is capital M by 3, that is mass of rod divided by 3 plus mass of bullet, and common term is L square omega. Common term is what? L square omega. Remember that according to law of conservation of momentum, momentum before system is equal to momentum after system. Initially rod is at rest, so its momentum is 0, but bullet is moving with velocity v and its momentum is L. So, the initial momentum of system is L, and that is equal to final momentum of system after collision is L dash. So, mv into L is equal to m by 3 plus small m into L square omega. So, this 1 L get cancelled, and we had omega is equal to, here mv is equal to mv is equal to m by 3. So, 3 can be taken as common, m plus 3m, m plus 3m into L omega into what? L omega. Now, take this to this side. So, 3 mv divided by m plus 3m into L, m plus 3m into L is equal to omega. So, 3 mv divided by m plus 3m into L, that is the angular frequency omega. So, out of 4 options, which option is correct? Look at option number C, 3 mv divided by m plus 3m into L. So, C is the correct option for this question.